We are now working on the very last new section in college algebra. I don't know about you, but I am extremely happy. This is 11.4, graphs of rational functions. I have emailed you these notes. You can look at them and write your notes down. Just kind of think about them as we're going. Or you can print them off, whatever makes you happy. A function of the form f of x equals p of x over q of x, where q of x cannot equal 0, is called a rational function because it's written like a fraction. You got a numerator and a denominator. That's what that word ratio means. Example, f of x equals 1 over x, f of x equals x plus 1 over 2x squared plus 5x minus 3. Are both rational functions. The graphs of rational functions have curves which approach imaginary lines called asymptotes. Graphs of rational functions have curves which approach imaginary lines called asymptotes. A-S-Y-M-P-T-O-T-E-S. Asymptotes. Graphs never cross vertical asymptotes. Vertical asymptotes are imaginary lines that curves get close to. To find the vertical asymptotes, set the denominator equal to 0 and solve. So if I want to find the vertical asymptote for this rational expression, I say, okay, x plus 2 equals 0. This has a vertical asymptote at x equals -2. Vertical asymptotes, just set the denominator equal to 0 and solve. Horizontal or oblique asymptotes, you have a few little rules. I'm going to write this in this form. I want us to all agree that this A is the leading coefficient in the numerator, B is the leading coefficient in the denominator, N is the degree of the numerator, and M is the degree of the denominator. With that agreed upon, the following rules will make it fairly easy to find these asymptotes. 1. If N is less than M, horizontal asymptote is y equals 0. 2. If N equals M, horizontal asymptote is y equals A over B. 3. If N is greater than M by exactly 1, divide to find the oblique asymptote. It'll be in the form y equals mx plus b. Number 4. If N is more than 1, larger than M, there will be no horizontal or oblique asymptote. Note, graphs cannot have both a horizontal and oblique asymptote. If they have a horizontal, they won't have an oblique, but they can't have both. You need these rules written down. You can go back to the email that I sent you and write them down, because I only have a few minutes in these videos. I cannot leave it here long enough for you to write it down as we go. Or maybe you can pause the video and write it down. There's your rules. I'm going to keep them handy so we can refer back to them. Example 1. Graph x over x squared minus 4. We're going to find the vertical asymptotes, the horizontal asymptotes. We're going to sketch the graph and see what it looks like. You're welcome to use your graphing calculator on all of these. But they're on every question, they're going to ask you, what is the vertical asymptote? What is the horizontal? So you need to know how to find them using these rules. Set that denominator equal to 0 and solve. When you solve that, you know you're going to come up with x equals plus or minus 2. There's a vertical asymptote at -2, and there's another one at 2. For some reason, they are specific on this, and they say, which is the vertical asymptote, which is the left vertical asymptote. X equals -2. Makes common sense. It's farther to the left on the graph. The right one is x equals 2. Let's sketch this graph and see what it looks like. Well, first we better find the horizontal asymptote so we know what we're doing. N is the degree of the numerator. It's 1. M is the degree of the denominator. It's 2. Since N is less than M, our first rule says if N is less than M, the horizontal asymptote is y equals 0. So now I've got all my asymptotes. I have to sketch this graph. I've just drawn it. Got to put a vertical one at x equals -2, another one at 2, and a horizontal one at y equals 0. Those are not really part of the graph. They're just dotted lines. You need those in there so that when you graph this with your calculator, you can kind of tell where to put those curves. So here I have my calculator. I've got x divided by, if you have any operation in numerator or denominator, you have to put it in parentheses, x squared minus 4, graph. It looks a little funny, doesn't it? This curve is telling you that this represents this red curve that I have in the third quadrant. In the middle, between these two, have a line that goes like this. Notice this one crosses the horizontal asymptote. It doesn't happen very often. It's just that, like the very first example I show, a curve crosses the horizontal asymptote. And then there's my last curve. Example 2. Graph 3x plus 2 over x minus 2. Vertical asymptote, x equals 2. Horizontal asymptote, n is 1, m is 1. If n equals m, y equals a over b. That's a, that's b. 3 over 1 is just 3. Horizontal asymptote, y equals 3. I've drawn another coordinate axis. I have put these dotted lines in here to represent my asymptotes. There's one at x equals 2, one at y equals 3. Notice this time I've got parentheses around numerator and denominator because I had operations in both. Open parentheses, 3x plus 2, close parentheses, divided by, open parentheses, x minus 2, graph. And I see these curves. And I sketch them in my graph, or either I match the multiple choice answer.